But next, we will have Engineer Jundy del Socorro from the Philippines. Perhaps you can describe to us, Jundy, like why you thought about looking into this problem of VOCs. Have you started monitoring? Do you see high levels already in the Philippines? And then maybe you can also tell us more about your plans for your activities on VOCs. Jundy, thank you.
Well, in the Philippines, we started with like in the 80s and the 90s. We started with manual monitoring. Start with the particulates, total suspended particulates. Then in the early 2000, then we included monitor PM10. Then just after, and some gases, but it's all manual. But um, in 2012, then came continuous monitoring instruments. So there's a combination of manual gravimetric particulates, those using manual for gases. Then we have this continuous monitoring for gases using the WASO differential optical absorption spectroscopy, which uses ultraviolet analyzers. From, uh, from early 2000 in the enactment of the Philippine Cleaner Act and up to this present, there have been good and bad news, okay, for fine particles and gases. For total suspended particulates, there's a decrease, but just after the pandemic, it went back again. Okay, so and same with PM10 and 2.5. Both of them are products of different policies from using biofuels in diesel, in gasoline, um, uh, revision of emissions quality guideline values. But then we have this SO2 NO2 and CO measurements. Most of them are in compliance with the annual guideline values. But when we go to the secondary air pollutants, we've noticed that for air zone, two stations, two areas. One is in Luzon, is in Laguna, and one is in south in the Davao, which is consistent. We have having problems with ozone. And just like what Professor mentioned, could be a product of complex chemistry, like if it has to do with the VOCs, the UV radiation. Then in 2012, just before the pandemic, we had this partnership with the University of the Philippines, Institute of Environment and Meteorology, to gather the data from the DOAS. But for VOCs, it's limited only to benzene, toluene, and xylene. Because all of those aromatic hydrocarbons are in our fuel standards, like it's around 35% by volume is the aromatics in our fuels in national standards, and for benzene it's around 2% by volume. So that's one suspect. Okay. So can we go to the next slide? Next slide. Next slide, please. So we quite surprised with the high results. Like for Metro Manila areas, it's around the concentration. By the way, in the Philippines, the unit for measurement is in microgram per normal cubic meter. Usually we correct it to 25 degrees centigrade. But it's around, for benzene, it's around 5 to 35 micrograms per normal cubic meter. Toluene is quite high. It could range up to 80 to 106. And then xylene is around 7 to 25 microgram per normal cubic meter. That is taken from more than 23,000 data sets for 3 years, and we're following data capture guidelines. And if we compare those data to what the annual guideline values of Japan, which is 3 micrograms per normal cubic meter. In Thailand, it's yeah, and it's quite low. In the US, I think we checked with some state like Rhode Island and Arizona, it's 0.1 for benzene. Yeah, and I think 100 or 200 for toluene. It's quite low. So so we know very little right now with VOCs. That's why this is part of hazardous a project called the hazardous ambient air quality standard program. Wherein, this is part of a long list of new pollutants that is not that are excluded in the Philippine Cleaner Act. So it includes black carbon, dioxin furans, hydrogen sulfide, heavy metals, the review of existing cardiac air pollutants. And we have said we only knew Proposal Zoo. Proposal Zoo was presented around 19, and there's a long list of VOCs. And hopefully, I think with the assistance of the EANET project, we could start next year, identify and start monitor other VOCs. We're not in the planning stage. It's not probably not total VOCs, but more VOCs other than the existing BTX. So and probably when the ultimate objective is to come up with the guideline values, and when I think that's very important in policy formulation, so we could inform and the government on what's are the health effects of this one and what are the main sources of VOCs. By the way, in our emission inventory, we conduct it every 3 years. VOCs contributes around, last 3 years ago, it's 94. Right now, it's 97% from the mobile sources. Okay, but that's total VOCs. We only know 3. So, but the number one suspect is really the transport sector, and that is something that we will be looking forward and will be coming up with policies, especially that in the type approval standards in the Philippines, we follow Euro 4, and hopefully by Euro 5, we'll be decreasing more stringent class 8C standards in the type approval standards. So basically, that's what's happening in the Philippines and looking forward direction in terms of VOCs. Thank you.